Has been a very important person in many people's lives, a very important person in the lives of Annie and me over the last 10 years since we've known him. Alphonso is a lot of things. He's a philosopher, he's a writer, he's an essayist, he's a traveller, he's a photographer, and he's an encounterer of people and the world. He is known as, of course, as the translator of the works of the extraordinary French phenomenologist Maurice Merleau-Ponty and also Emmanuel Levinas. His books include The Community of Those Who Have Nothing in Common, one of my favourite titles, Foreign Bodies, Dangerous Emotions, Trust, Body Transformations, First Person Singular, Violence and Splendour, and most recently, Irrevocable. That's just a selection. And Alphonso's, I read somebody who said once, and this is completely true I think, has invented his own genre of writing. In many of these books what he does is bring together his extraordinary knowledge of philosophy, of European philosophy, of many different kinds of philosophy, with his own experiences of encounters, of people, of places, of animals, of ideas. For Alphonso Lingis, there is no mind-body split. His work is visceral and bodily and intellectual and spiritual and moral and political all at once. In Māori culture, as you will know, one form of greeting is the hongi. And the hongi is where you touch foreheads together. And the way I have had it explained to me is that when you hongi, you imagine that you're not just meeting the other person, you're encountering their whakapapa, as Kirsty talked about it. And you'll remember that Witi Ihimaera also talked about the whale rider Pai hongiing the whale and recognising the whale, thereby truly recognising the other person, animal or human. And Alphonso's writing and Alphonso's practice, it seems to me, is very much like a hongi. It's about encountering in the deepest, fullest, warmest and most compassionate sense. So we're just so pleased to have him here. Please welcome Alphonso Lingis.
Colonizing. 1. Colonizing North America. In 1585, Spanish founded a permanent settlement in North America in St. Augustine, Florida. And in 1607, English founded a colony in Jamestown, Virginia. 1 million colonists had arrived by the time the 13 colonies declared independence in 1775. And in the next century, some 40 million more people, half of them indentured servants or convicts, 500,000 African slaves, were settled in the United States. Historians calculate that between 2 and 18 million Native Americans inhabited the land. They were killed for the most part by the imported pathogens of influenza, bubonic plague, pneumonia, yellow fever, smallpox, and malaria, but also by open warfare, and were reduced to 250,000 by 1890. By 1875, the colonists had deforested the whole East Coast from Maine to Florida. Deer were hunted for meat and also for deer skin shipped to Europe in vast quantities. Researchers estimate that territorial United States had 40 million deer in 1600. By 1900, there were 300,000. The fur trade in North America slaughtered bears, marten, lynx, otter, mink, foxes, and especially beaver. Researchers estimate that there were up to 400 million beaver in North America in 1600. In 1900, there were 100,000 in remote stretches of Canada. In the 17th century, North America contained more than 60 million bison. They were hunted for their skins and tongues, with the rest of the animal left to decay on the ground. The federal government promoted bison hunting to remove the main food source of the Plains Indians and thus pressure them onto the Indian reservations. President Ulysses S. Grant saw the destruction of bison as a solution to the country's Indian problem. In 1899, there were about 541 bison in existence. Researchers believe that in 1600, there were at least 10 million wild turkeys in North America. By 1930, they had been totally exterminated in Canada and most of the United States, where there were 30,000 left. Snowy egrets, white ibis, great blue herons, owls, and 40 other bird species were slaughtered annually for their feathers, for the hats of women in Britain and Europe. In 1912, the feathered skins of 1,600 hummingbirds sold for 2 cents each. Passenger pigeons were the most numerous birds in North America, perhaps in the world. Researchers estimate the population in 1800 at 3 to 5 billion. John James Audubon described a flock of passenger pigeons a mile wide that passed overhead, darkening the sky for 3 days. Gathering in huge flocks in trees, they were slaughtered by buckshot, poisoned, killed by fire, sending smoke or sulfur fumes into the nesting birds. They were shipped to cities for food, but also killed to protect grain crops and fed to pigs. In 1878, the last large nesting area was decimated by shooters. The last wild bird seen was shot in 1901. The Cincinnati Zoo had a female named Martha. The zoo offered huge rewards to anyone who could find her a live mate. In vain. Martha, the last passenger pigeon, died in 1914, aged 29. The Carolina parakeet was the only parrot species native to North America. In 1918, the last Carolina parakeet, named Incas, died at the Cincinnati Zoo in Martha's cage. 2. Colonizing the emptied continent. The 20th century saw a movement to preserve areas of natural grandeur. Yellowstone was the first national park established in 1872. Today there are 60 national parks where nature as it was is protected for posterity. Sport hunters supported legislation to conserve deer, moose, elk, and turkeys as game animals, and to establish colonies of them in states where they had been exterminated. In 1973, the Endangered Species Act was passed by the federal government, extending protection to species not prized by hunters for game. When by 1930 in the United States, wild turkeys had been exterminated throughout the land, Sport Hunters Association supported efforts to establish colonies of turkeys where they existed no more. For more than 20 years, eggs were gathered and pulled strays in pens and then released. Virtually none of them survived. They had not had parents to teach them the terrain, the foods available, and the dangers to flee. Conservationists concluded that success would only come from capturing wild turkeys in nature and transporting them in other places. But the surviving birds were extremely wary and difficult to trap. Finally, in 1951, the newly invented cannon trap was successfully used to trap significant numbers of wild turkeys. By 2001, wild turkeys were found in every state except Alaska, estimated total 7 million. The 137 Hawaiian Islands consist of many small islands, which are habitats to small populations of species, which in many cases are found only on one island. Conservationists propose to colonize several islands with these species. The proposal divides those who are concentrated on saving individual species from those who concentrate on saving ecosystems. In 1968, several species of birds were colonized on more islands. The 52-year effort to establish colonies of whooping cranes reveals the intractable problems that may be involved. Whooping cranes, up to 1.6 meters tall, are the tallest North American birds. They are white with red crowns and black-tipped primary wing feathers. Once found throughout the North American Midwest, in 1941 there were but 21 cranes in existence in nature and 1 in captivity. There were only 3 or perhaps 4 breeding pairs. That year, 2 more cranes found injured were put together in captivity. The female laid 50 eggs over the next 25 years, but only 4 chicks hatched and all of them died in infancy. Captive breeding had failed. In 1954, the summer breeding grounds of whooping cranes were discovered in the far north of Canada. They wintered in Texas, migrating seasonally 3,500 kilometers. Researchers now discovered that the cranes laid 1 or 2 eggs. If they laid 2 eggs, the second either did not hatch or the chick rarely survived. In 1967, they began gathering these second eggs from the nests, shipping them to the Wildlife Research Center in Maryland, where they were put in the nests of sandhill cranes. Canadian researchers gathered second eggs from whooping crane nests and put them in the nests of sandhill cranes in the wild. When the whooping crane offspring reached breeding age at 5 to 7 years, they behaved as sandhill cranes and did not mate one another. The Maryland Center then began inseminating female cranes artificially several times a season, hatching the eggs in incubators, and launched a very labor-intensive project of raising them. Caretakers in white robes with faces covered and carrying puppeted crane heads and recorders playing crane calls taught the chicks to eat, to drink, to swim, and took them on hour-long exercise treks 5 times a day. Dozens of cranes were raised in this way in the center. The researchers believed it important to establish a second migratory route and flock in case the disease or hurricanes might wipe out the existing flock. In 2001, they played the sound of an ultralight airplane along with the eggs in the incubator. Then caretakers taught newborn chicks to follow an ultralight airplane. When they were half grown, they were taken to the proposed new summer breeding ground in Wisconsin. There, as the young cranes followed an ultralight airplane, the plane rose into the air to teach the cranes to fly. At the end of the summer, an ultralight airplane led them 2,000 kilometers south to the proposed winter range in Florida. The birds memorized the trip perfectly, and the following spring, they flew of themselves back to Wisconsin. The following 2 years, cranes raised in the Maryland Center were released into this flock, and they joined the migrating flock from Wisconsin to Florida and back. But by 2008, out of 250 whooping cranes released in the flock, but 83 were still alive, and only 6 pairs mated and raised chicks in the wild. The researchers concluded that cranes raised by the costumed humans failed to learn adult and mating behavior. Meantime, non-migratory colonies of cranes raised in the Maryland Center were established in Florida and Louisiana. The expectation was that these flocks, not enduring the hazards of migration, would survive better. But the cranes there too did not successfully reproduce. In 2017, the center suspended the program with costumed human foster parents and ultralights. Now researchers located nests in the Louisiana flock and identified eggs in them that were sterile. They replaced them with eggs taken from the incubators in the Maryland Center to hatch in those Louisiana nests and to be raised by whooping cranes. In 2018, there were 505 whooping cranes in the original migratory flock, 181 in the secondary migratory flock in the 2 non-migratory colonies, and 163 in captivity for a total of 849 whooping cranes in the world. In 2018, the Trump administration cut the budget of the Maryland Crane Center and the breeding program was shut down. 3, colonizing new climates. Global climate change is altering average temperatures in different regions and latitudes, altering rainfall patterns and augmenting the location and intensity of hurricanes, flooding, and wildfires. In the normal course of events, when an ecosystem is affected by these things, some animal and plant species evolve adaptations to the changed environment, and some migrate to new areas where conditions are similar to those in which they had evolved. But climate change is now taking place so rapidly that few species will be able to evolve adaptations fast enough to adjust to the new conditions in which they find themselves. Ecologist Camille Parmesan estimated that every species range is shifting 6.1 kilometers toward the poles every decade, with spring events occurring 2.3 days earlier every decade. Plants and reptiles move too slowly to shift to new latitudes in the time that will be necessary. Plants and animals who live above the tree line on mountains and those who live in wetlands may not be able to move to suitable habitats further north or in the southern hemisphere further south. Ecologists are facing the need to implant colonies of plants and animals in new regions. Colonies of plants and animals of considerable economic importance, such as strains of rice or winter wheat, or forests of tree species harvested for lumber. But also colonies of plants and animals that today exist in small populations or populations in restricted territories. In the province of British Columbia in Canada, 25 million hectares are given over to commercially harvested forests. Some 240 million seedlings are planted each year in the logged forests. When these trees are harvested, 60 to 80 years after they are planted, the climate could be 3 or 4 degrees warmer, exposing the trees to maladaptation and health risks. Researchers at the Assisted Migration Adaptation Trial have planted seeds of 15 species of trees at 48 reforestation sites from Northern California to Southern Yukon to observe which seed stock will do best in the different climate conditions. Commercial nurseries that supply thousands of plant species for gardens and orchards, and also ornamental plants, are already beginning to reassign them to different climate zones. Thus, millions of farmers and homeowners are moving crops, orchards, and ornamental plants toward the poles. The Dixon National Tallgrass Prairie Seed Bank, USA, at the Chicago Botanical Garden has collected seeds from more than 500 plant species found in tallgrass prairie in the American Midwest. They can be used to establish colonies in new regions as climate change advances. The Millennium Seed Bank, in a nuclear bomb-proof, multi-storied underground vault near London, is the largest seed bank in the world. It aims to store seeds of every existing plant species. It is estimated that the botanical gardens dispersed around the world contain some 1/3 of all plant species. A communication network is being established to program the transfer of some of the specimens to botanical gardens in latitudes that climate change will make more suitable for them in future decades. Many national parks and wildlife refuges were created to protect habitats of endangered species. Colonies of these species may have to be established in parks in other zones. Many of the nuclear power plants constructed in the mid to late 20th century are now coming to the end of their productive lives. Across Europe, there are 78 reactors at 38 sites already closed, with a further 126 reactors at 52 sites scheduled to be closed by 2025. Human activity will be restricted on these sites for decades, even for centuries. They could well be colonized with plants and animals whose present habitats will have become unsuitable for them. The work of colonizing regions with mammal, reptile, insect, fish, and plant species that will not be able to relocate by themselves will require intensive study of suitable conditions for each species and immense resources. It can be expected that rich donors and also private individuals will adopt a favorite animal or plant and colonize it in more climate-suitable region. The critically endangered Florida Toraja is an evergreen tree that was logged heavily in the 1950s, and in the 1950s suffered a catastrophic attack of fungus. There are now only 200 stunted trees left and only 10 able to produce seeds. An itinerant Unitarian preacher named Connie Barlow took an interest in this tree and learned that it was once widespread across North America. It was the glacial advance in the last ice age that pushed it down to this Florida refuge. She reasoned that it would now find its former range suitable. She acquired seeds and planted Florida Torajas on 2 privately owned lands in North Carolina. She formed a group with some biologists and interested lay people called Toraja Guardians to find more places to plant the Florida Torajas. As climate change advances across the planet, conservationists may have to establish colonies of thousands of species of animals, birds, insects, and plants in new locations. Not only species, conservationists may have to move entire networks of species. A habitat is an ecosystem where a large number of plant, animal, and insect species exist, as well as fungi, bacteria, in soils with specific mineral and chemical compositions. These colonies will be subject to predators and pathogens that exist in the new locations. Colonizing an ecosystem with new species can result in these becoming invasive, crowding out the existing species there, ultimately reducing biological diversity. Biologists and indeed the general public think of rabbits and cane toads in Australia and shudder. But the vast majority of species that have become invasive are species that have been transported from one continent to another or from continent to islands. Researchers Mark Williamson and Alistair Fitter calculate that but 1% of introduced species become invasive. 4, colonizing keystone species. In recent decades, ecologists have identified keystone species, species whose removal from an ecosystem results in a fundamental alteration of the whole system and a loss of species diversity. In Yellowstone National Park, created in 1872, wolves were hunted to extinction in the park. Indeed, they had been, by 1960, exterminated everywhere in the United States, save for one small retreat in Minnesota. Elk in Yellowstone Park multiplied in such numbers that the park was being denuded with rampant soil erosion. In 1995, after much research and controversy, a colony of 14 wolves was established in the park, and the following year, a colony of 17 wolves. In the years that followed, it was found that the elk population was reduced in half. Aspens, cottonwood, and willow trees recovered and flourished. Beavers who are dependent on willows for their winter food increased. Berries recovered and flourished, and with them grizzly bears who feed largely on berries. Coyotes were reduced and foxes increased, and wolverines, ravens, bald and golden eagles who scavenge on wolf kills increased. North America had mammoths, cheetahs, glyptodons, saber-toothed cats, dire wolves, giant ground sloths, giant beavers, and short-faced bears, all of which became extinct about 10,000 years ago as humans arrived on the hemisphere. Horses and camels originated on the North American continent and migrated across the Bering Ice Bridge to Asia during the last ice age. These large mammals cleared trees, created grasslands, spread seeds, turned over and fertilized the land. When they disappeared, the far north became tundra covered with scrub brush and boreal forests, mosses and lichens, and the arid south became desert covered with mesquite. In 2004, media mogul Ted Turner met with a group of conservation biologists, ecologists, and paleontologists in Turner's huge ranch in New Mexico, and worked out a plan to colonize the mesquite-covered desert in New Mexico with lost keystone species, American bison and giant desert tortoises. The extinct megafauna would be replaced with their close relatives, Przewalski horses and Bactrian camels, elephants to replace mammoths and mastodons, African to replace American cheetahs. The northernmost 25% of the northern hemisphere, North America, Eurasia, Siberia, is covered with permafrost, which has sealed undecomposed carbon-rich organic matter. In Siberia, this carbon-rich layer is many meters deep. With global warming, the permafrost is melting, and bacteria are beginning to decompose the organic matter, releasing carbon dioxide and methane, accelerating global warming, which in turn melts more permafrost. Fossil discovery shows that Siberia had immense herds of large mammals feeding on grass. In northeastern Siberia, geophysicist Sergei Zimov created in 1988 Pleistocene Park, a now 160 square kilometer fenced-in zone, and populated it with reindeer, Siberian roe deer, moose, Yakutan horses, musk oxen, wood bison, Altai wapiti, wisent yak, Bactrian camels, snow sheep, and saiga antelope. They are a mix of grazers feeding on steppe grass and browsers feeding on woody plants. Together, they break down the boreal forest, break up the soil, spread seeds and fertilizers as they go. Zimov plans to increase the park to 600 square kilometers. The predators are already there: lynx, tundra wolves, Arctic foxes, Eurasian brown bears, Siberian tigers, the wolverines, red foxes, and sables. Over just a few years, Zimov watched the tundra turn into grassland steppe. Whereas boreal conifer forest absorbs heat, grass reflects heat in summer, such that the land does not warm up so much. In the winter, the tundra is covered with snow. The atmospheric temperature can fall to minus 50 degrees centigrade, but the ground under the insulating blanket of snow remains a constant minus 5 degrees centigrade. The herds in Pleistocene Park root for grass under the snow, exposing the ground beneath, which becomes significantly colder, averaging minus 30 degrees centigrade. Where there are herds of megafauna across the tundra in Siberia and Canada, they will significantly diminish permafrost melting and break carbon dioxide and methane release. Could we do better, even better? Could we implant colonies of the extinct megafauna in these ecosystems? Every year, more and better preserved mummies of woolly mammoths are being excavated. American, Russian, Japanese, and Korean laboratories are at work on resurrecting mammoths. In the United States, the Mammoth Recovery Project is being pursued in the laboratory of geneticist George Church at Harvard University. Asian elephants are the closest extant relatives of woolly mammoths. Bits of mammoth DNA are being extracted from mammoth bones and replacing the corresponding segments of Asian elephant DNA. The reconstructed mammoth DNA will be implanted in an egg of an Asian elephant, and when the embryo begins to take, implanted in an Asian elephant or in a synthetic womb to grow into a fetus and be born. Church predicts success within the decade. He has pledged that the resurrected mammoths will not be kept in a zoo, but freed in Zimov's Pleistocene Park. The other deconstruction project being pursued in the United States is at Stanford University in California, where work is proceeding apace on the passenger pigeon. The enormous flocks of passenger pigeons descended on forests, consuming immense quantities of nuts and acorns, flying at great speeds up to 100 kilometers an hour and great distances, spreading forest plants. Thousands would descend on trees which broke under their weight, opening clearings in the forest for greater diversity of plants and animals. With their disappearance, the fallen nuts and acorns of the forest now feed ever greater multitudes of deer and mice, the carriers of Lyme disease. Restoring the passenger pigeon is then not simply a sentimental project or an act of remorse. The passenger pigeon was also a keystone species. I conclude with the abstract of this paper. Beginning in 1585, colonies of a species that proved unstoppably invasive and predator were established in North America. The European colonists drove the Native Americans to the brink of extinction and emptied the continent of forests, bison, deer, beavers, turkeys, passenger pigeons, and hundreds of other species. However, beginning about 1900, hunters' associations supported efforts to establish colonies of deer, moose, foxes, and turkeys where they had been exterminated. The 50-year effort to bring back the whooping cranes from extinction shows how difficult that may be. But the establishing of now flourishing colonies of turkeys in every state, even where they had never existed, is a spectacular success story. Today, the fast advancing climate change is making habitats where they evolved unsuitable for thousands of species of plants, reptiles, insects, mammoths, birds, and fish. Many of them will not be able to relocate to new zones or will not be able to do so in time. It will be necessary for forest management, farmers, conservationists, and private individuals to establish colonies of these soon-to-be endangered plants and animals in new zones. Many regions are degraded because keystone species were eliminated or exterminated to extinction. To recover species diversity, it may be necessary to reintroduce them, even to resurrect them. Can you turn it off? That, of course, is a famous painting by John James Audubon. Can we turn the... Oh, it's off. Okay.
Thank you so much, Alphonso. A talk by Alphonso Lingis, like an Alphonso Lingis essay, or indeed an evening spent with Alphonso Lingis, is a multi-dimensional experience, and that certainly was as well. And I want to thank you, Al, too, and also Watco did this for us, for bringing, sometimes people say, well, we have animal studies conferences and there's no animals at them, other than human animals, but of course we've heard at least the voices of animals, both in Watco's presentation and in ours, so thank you for that. And we have time for questions and conversation and a very, very broad canvas indeed to work with.
Thank you. So the picture that I get is that we're trying to address the effects of climate change by certain methods of conservation, transplanting colonies and ecosystems of animals and birds where they can thrive. So in a sense, we're trying to save them. But the methods we are utilizing are also invasive. And I'm sure there are human errors there that have fatalities also. So the whole thing, I find it wonderful, but does it make sense? Will it grow a better ecosystems of all living, that is my question.
Well, one thing I might reflect is that ecosystems are not permanent. There are always new ecosystems. There are new ecosystems people have studied the new ecosystems in cities. Of all sorts of plants and animals now flourish in cities. For example, one of my favorites are pigeons that are now living in every city in the world, from North Cape and the far north of Europe to the very bottom of South America. So they have flourished and they do very well in cities because, in nature they live in cliffs. And so they find in the high rise of cities places where they can hide their nests that predators can't get to. So I think certainly as we move, we're going to have to move thousands of species if they are going to survive. They will create new ecosystems where they're moved to. And no doubt there will be terrible errors, and a great deal of research will be necessary. I'm also staggered at the resources that will be required. I mean, climate change is now going so rapidly, 6 kilometers a decade, that it will require enormous resources right away, which governments show no sign of recognizing yet. I brought up this case of this preacher who, she's just an itinerant preacher who took an interest in the critically endangered species of tree in Florida and created her little website of the Toraja Guardians, to save it. So I think that I think it's a kind of example of what individual people can do. And it's true that people who plant gardens, either for food or ornamental gardens, are already moving plants, toward the poles themselves. So, I moved to Maryland about 18 years ago and started planting a lot of things. And I see now in the nurseries, the nurseries give you which climate zone is suitable for. And I see even in 17 years in Maryland, our local nurseries are already reassigning some of these plants to different climate zones. So, people planting gardens and so on will be moving some of these species to more suitable environments.
I wanted to ask, is this rescue effort what we should be trying to do? Is it possible that actually we should be rethinking and what the possibility is? I've got two examples. First of all, I thought your description of resurrecting the woolly mammoth, I cannot believe that whatever we wind up with will be a woolly mammoth. And the second example is New Zealand. We have many species here, such as deer, pigs, goats, and so on, and wallabies, which have no predators, no apex predators. They were not introduced by the colonists, and I think we have to feel grateful for that, but I'm not quite sure. I don't think we have any idea of how to move forward on managing those populations, let alone managing those populations and protecting our native birds. So what do you think about the possibility of some other vision of the future?
It's certainly a big issue. Who was I talking to earlier? I don't see him. Who was very skeptical about whether this would even happen, whether the scientists would succeed. I read 5 books on resurrection science in recent months, and the researcher at Harvard is a very distinguished geneticist. And people say that if anyone can do it, he can do it. And he's convinced he'll have the woolly mammoths within 10 years. So, we'll see. And the researcher working to resurrect the passenger pigeon, and it's the same sort of procedure. You take the closest extant relative of the passenger pigeon. And now, apparently, gene splicing has become very cheap. It used to be very expensive to do. But now it's apparently, they have technologies to do that. That makes it very cheap. So then you're going to take the closest relative, and then you're going to take the DNA samples from, really there are dozens, maybe hundreds of skins of passenger pigeons in in natural history museums, and then replace it. In the case of the passenger pigeon, you have this issue. The passenger pigeon was extremely gregarious. So that was its form of life. And so if we begin to be able to reproduce large flocks of them, they're going to find North America quite changed from when they flourished, a century ago. So these are all issues. But all I can say is that in the books I read, these researchers at Harvard and at Stanford are very confident that they will succeed. In both cases, they say they will succeed within a decade. In fact, George Church, I recently had my DNA, studied, and it turns out I'm 4% Cro-Magnon Neanderthal, which is true of virtually everybody in Europe. So people brought up the issue, well, how about resurrecting the Neanderthals? That would seem quite easy to do. In fact, George Church jokingly said, "All I'm looking for now is an imaginative woman." So they have confidence and to reintroduce woolly mammoths in Siberia, because Zimov he's a geophysicist, and he's quite convinced that was grassland when all those giant mammals ate there. You know, grass is the fastest growing plant, and so it was able to feed these huge herds of giant mammals, you know, at that time, all of whom disappeared 10,000 years ago as humans arrived. He thinks that these mammals will recreate the grassland, you know, by spreading seeds, by breaking up the soil, and so on. So, in that case, it would return northern Siberia to the kind of ecosystem that existed when the woolly mammoths roamed the land.
Yeah, I just have a comment. As a Native American, sometimes I, feel that these, emphasis on this discourse erase the resistance of the other species as well as us, because as terrible as this has been, this colonization, we're still here, and other keystone species are still resisting. And we can learn and get in solidarity with other species. So I feel uneasy sometimes about overemphasizing all this discourse and not putting attention on what other species are doing, especially these keystone species, to resist, and we can learn and how we can support. So it's very interesting, but I also caution against overemphasizing this and centering this discourse and not learning from what is here from other species too.
Yeah, certainly researchers will have to study the environments that they're moving plants and animals into. And but I am very struck by that statistic those two guys did. They said that only 1% of imported species become invasive. And most of the important species that became invasive were moved from one continent to another. So I know, I was teaching in Pennsylvania, and some 20 years ago, the Gypsy Moths arrived. They came from Europe on cargo ships and so on. And there was great talk that they were devastating our forests. As you would drive by, you saw whole trees that were completely defoliated. And in fact, I had a little land in the forest, and they were going to spray my land. And I got very upset by that. I said, you can't just kill one bug. You're going to kill other things that the birds depend on and so on. So I refused to have the land sprayed. And a biologist told me that the gypsy moths in Europe are not out of hand, because they have, things that destroy them. They have little types of mites and lice and so on. They kill the gypsy moths. And what's happened is that they arrived in North America and they don't have these enemies, but they will have them, And it was marvelous. 20 years later, the gypsy moths were very rare. Occasionally you see these trees killed, but they had become very rare. So they had become integrated into our North American environment, and with their enemies, and had ceased to be a dangerous and invasive species.
Tēnā koe e koro, ngā mihi nui I tō kōrero. Thank you for your talk. I genuinely found it fascinating. I just want to make a comment and hear your thoughts in relation to this. I've been doing some thinking about climate change recently, and I am no longer referring to it as climate change. Instead, I'm talking about climate crisis. And I think that way of speaking about it is very important because it is a crisis, and when we simply talk about climate change, we are diminishing the importance and the significance of what's happening. One of my responses or reactions to your talk was that I feel that this talk about resurrecting species, especially relocating species and ecosystems, is still anthropocentric and problematic for that reason. One whakaaro or thought that I have around saving the world, which is essentially what we're talking about, is that we need to be proving that we are worthy of the world that we are inhabiting and the impact that we're having on it. And reflecting on what you have said about our use of animals and ecosystems and non-human nature, our use of it, which is what this is, I think, with all of the potential harmful implications of that, because there are potential benefits but also potential harmful implications, I guess I'm interested in your thoughts on whether these sorts of interventions are proving to ourselves and to non-human nature that we are worthy of the world that we're trying to protect and preserve.
I kind of think we have no alternative. I think we have to try to save biodiversity. And right now we have this very urgent problem of the climate shifting and so many species being unable to adapt or move. You know, I'm thinking of, for example, all the creatures who live above the tree line on mountain ranges. You know, they won't be able to move on to the next mountain range without help. I guess we have to, I feel we have to help them. and for some of the species, for example, trees grown for lumber, I mean, the foresters are doing this. They are calculating what the temperature will be in 60 or 80 years when the trees they planted will be ready to be harvested. So they are doing that. And also all the nurseries who produce new hybrid types of grains and food plants are already thinking about this necessarily. I think that we have to extend that to the animals that are not commercially important to us. Yeah.
Alphonso, thanks for that talk. I think it brings up a lot of really important adjacent issues. For instance, I've not heard any discussion, but you brought it up, about what we already have started, biotechnology, for instance. And there are lots of reasons why biotechnology, if it continues, I think will make things worse off. In terms of remaking the woolly mammoth, I doubt, as someone already pointed out, that we will get a woolly mammoth. We'll get something, but I don't think we're ready really for what that might be. And you know, whether a scientist is at Stanford or wherever they are, the idea that if one can do it, then we must do it is, I think, a central issue in where we are right now. I don't think we'd have the kinds of issues that we have right now with climate change, species extinction, habitat loss, all these things, if we hadn't had that idea, especially in the United States now, but overall in civilization, that progress, always progress, is a good thing, and that technology will get us out of this. I don't agree with that. I have been very involved in my life in technology, and it's not going to save us. And I don't think remaking a woolly mammoth is really going to happen. Or if it happens, it will do anything that is positive for all the lives of animals, all the other lives of animals in the world. So I think you bring up all these things. A little part of me wonders if you're being ironic.
Well, the project to resurrect the woolly mammoth is not simply out of curiosity. The idea was that it was a keystone species in Siberia. And George Church has already advanced quite far in, you don't find DNA intact that old. So the woolly mammoths went extinct 10,000 years ago, but you find pieces of DNA. So that's what he's, inserting in the model DNA of the Asian elephant. So he's already figured out the blood of this animal, that it could survive, in much colder temperatures than Asian elephants. So he's found the DNA that would control the blood and also the hairiness. So he thinks he's advanced pretty far. I think the question that perhaps you have in mind is that the woolly mammoth didn't just sort of exist by itself. It exists in a habitat with other animals and plants and so on. So the woolly mammoth isn't like some sort of platonic species, by itself. It is a woolly mammoth because it exists in an environment, a habitat, other forms of life. Perhaps the woolly mammoth that he resurrects will not have all the behaviors and environment of the woolly mammoths that went extinct 10,000 years ago. But his idea is that it was a keystone species of all the great mammals of the far north, and it would be important to replace them. I mean, it's a little bit like reintroducing wolves in Yellowstone. Well, he said he's going to put it in the Pleistocene Park in Siberia.
Is it not the case that the last talk of the day is always the one that raises the most questions? But the talk just before the last talk made us all very, very hungry. So I'm just going to allow 2 more questions. And the first is from Helen.
I was just going to pick up on Carol's notion of the idea of progress. I would think what we have to work on now are ourselves and our ways of thinking about things, so that, as you point out, it's not progress, it's not greed, and that greed includes greed for our own species, i.e. human overpopulation, which in fact is the underpinning of all our current problems. And really we have to address that together with our own attitudes, and that a lot more effort needs to be put into changing our ways of thought so we learn like animals just to be, just to exist, to have enough to exist, and that's it, you know, and not be pushing further. I don't want to mention the woolly mammoth, but I just did. You know, I'd love to see one, but, you know, I don't see any point in money going into that technology.
Well, I think there is this point, is that certain projects will captivate public attention, and certainly resurrecting the woolly mammoth and the passenger pigeon will. You know, when I was a boy, in, I don't know, 8 years old or so, I read about the extinction of the passenger pigeon. And actually, pigeons were my first friends. My father was a farmer, and we moved to a new farm, and he found a nest of pigeons in the silo and gave them to me. I was 4 years old. So I had a kind of affection for pigeons, and when I heard about the extermination of the passenger pigeon when I was like 8 years old, it made a very profound effect on me. It made me, I just had a sadness that we would wipe out a whole species forever, you know? And so that for me, the passenger pigeon is special. And there may be all kinds of other birds that are important to rescue, but it seems to me that some of these celebrity animals, you know, would captivate public attention. And I think resurrecting the woolly mammoth, and with it, this whole idea of stopping the melting of permafrost in the far north, recreating grassland up there with large mammals, you know, I think that it would excite the public and interest people in the things that are happening to species and the things that are possible to do. So,
Well, you have certainly excited.
Just quickly, I suppose I find it quite bizarre that we're talking about resurrecting a species which was essentially in the Arctic tundra, and here we are having a global warming planet. So it's the complete opposite. Have you got any thoughts on that?
I'm not sure I understood that.
So the woolly mammoth was obviously existed at a time when the planet was a lot cooler, and we have global warming, so the planet's obviously becoming a lot hotter, but we're not really thinking about that. We're still wanting to resurrect something which essentially lives in the Arctic tundra. Yeah?
You know, the melting of the permafrost is the biggest problem in terms of global warming. I mean, that's releasing incredible quantities of carbon dioxide and methane in the air. We know that the woolly mammoth ate grass.
I think it's Bruno Lawrence. I think it's Bruno Latour. Bruno Lawrence was a drummer in a fantastic New Zealand 70s band, and an actor, and he had at least 4% Neanderthal in him. I think it's Bruno Latour who said nobody knows what an environment can do. And nobody knows what a talk by Alphonso Lingis can do either, but I tell you what it does do is it gets people talking. So please join me in thanking Alphonso for such a spirited